Hello everyone, so welcome to the new module that is number system, and the first topic that we are going to study today is called as classification of numbers. So now this is a slightly theoretical topic because we have to initially know the different varieties that the numbers have and what are the different classifications for them, because going forward in the next subsequent chapters all these things are going to play a huge role when it comes to solving the question. So that's the whole aspect that you have to know very clearly which type of numbers are exactly what, and that is what we are supposed to see today. So let's start with the first one, that is how first and foremost the numbers should be classified. So obviously the first part has to be real numbers and imaginary numbers. So now let's try and understand what are real numbers. So real numbers are those basically which after squaring should give you positive results. And if you think from that perspective, you would realize our entire system has real numbers because they can be negative, but after squaring, they will give you positive. They can be decimal numbers, after squaring, will give you positive numbers. They can be proper numbers, which after squaring again gives you positive answers. So, all the numbers that we use, they all are real numbers basically. So, simple definition, just do remember that after squaring gives you positive result. Automatically, what is imaginary numbers? So imaginary numbers are the ones that even after squaring gives you negative result. Now again, when you think from that perspective, you would realize none of the numbers that we have in our system are like that, because normally they do not exist. So as the name suggests, you would have realized by now that imaginary numbers don't actually exist. It's a hypothetical concept, it's a made up concept. Now also, the first imaginary number which was defined ever was iota, which is I, which has a value of square root of -1. So what happens is, even after squaring, you get I square as -1 only, because after squaring the square root goes off, but the value still remains negative. And when you again think from that perspective, none of our numbers classify under this idea. So hence it's a hypothetical concept, imaginary concept, made up concept. One good thing about our syllabus is that any which is we are not gonna have any applications or any studies basis that. So we're gonna skip this and we'll continue further. So real numbers are further classified into two types: rational numbers and irrational numbers. Now, what are they? So, for example, rational numbers. So, all the numbers that you can express as a fraction, which has one numerator and one denominator, all such numbers can be called as rational numbers. Obviously, one condition: the denominator, for example, q, should not be equal to 0. Because if the denominator becomes 0, then obviously the value becomes infinity, which is not possible. So, any number which can be done as represented as fractions called as rational numbers. Then obviously there is something called as irrational numbers. So irrational numbers are the ones that you cannot express as fractions. So they are called as irrational numbers. So that's the next idea. Then after this, what's the next piece of information that we have to know? The rational numbers are further classified into two types: integers and fractions. Now let's try and understand what are integers. So, if given a choice of all these numbers and we have to identify which of the following are integers, so one very simple thing you have to remember: they can be positive as well as negative. The only difference is they cannot be in decimals, they have to be proper numbers. So, for example, a number like, let's say, 8 or 17 or -11, all these are your integers. So minus 2.3, 9.6, they are all not, they are not integers. They are decimal numbers. So simple sa definition: numbers without decimal, they are called as integers. But they can be positive as well as negative. for example. Then the next one, we'll study decimals separately. So I'm keeping it on hold for a time being. Let's not break the flow. So as we were discussing, rational numbers are further classified into two types, integers and fractions. We have seen integers. Now let's see the fractions. So fractions, obviously one numerator, one denominator, but these fractions, they are sub-classified into three more types, for example. So for example, there is something called as proper fraction, there is something called as improper fraction, and then there is something called as mixed fractions. So these are the three types of fractions. Now, what are proper fractions? So proper fractions are the ones which has the numerator as less than the denominator. Now think about this. If you divide by the bigger number, your answer will definitely be less than 1. So all the proper fraction have this criteria or the characteristic that their values are always less than 1. These are few examples. For example, 5 by 9, 12 by 17. So all the answers will be 0 point something. Numerator is lesser than denominator. All these are called as proper fractions. Then automatically the second one has to be improper fractions. So improper fractions exactly ulta. Numerator will be more than denominator. So if the numerator is more than denominator, of course the answer will be greater than 1. And these are few examples of that in terms of improper fractions. And then there is a third type of fraction, which is mixed fractions. So probably you would have seen such types. And when you simplify the type, for example, if you do not know how do we simplify, let's take this example to 1 by 3, which represents this kind of structure. So this becomes 2 into 3 plus 1. So that gives you 7 upon 3, for example. And after simplifying any mixed fraction, you will realize one very, very important thing, that the numerator is greater than the denominator. So if numerator is greater than the denominator, we have already studied this just now, they are called as improper fractions. So that tells you the idea that mixed fraction is not a separate criteria as such. It is just another way of representing improper fractions, basically. And this is how the simplification happens. So these are the three main types of fraction: proper fraction, improper fractions, and mixed fractions. And this is how you should be able to figure them out in the same manner. Then was the next one. We were studying integers, numbers without decimals. Point में नहीं होना चाहिए, positive negative हो सकता है. Integers also has three subtypes mainly: negative integers, zero, and positive integers, for example. So negative integers, what are negative integers? Obviously clearly you can see that on the number line: -4, -3, -2, etc., etc. Then there is 0, and then there are positive integers which are 1, 2, 3, 4, and so on and so forth. Now these positive integers only, they are called as natural numbers, and if you add 0 along with them, together they are called as whole numbers. And I hope all these words are probably now striking to your mind, because we have done this already in the school days. So these were the names that are very, very crucial: natural numbers, whole numbers, etc., etc. The point is, going forward, examiner is going to use all these words in the question, so it is very important for you to know that first. Only then you will be able to solve it correctly. So these are the three types of integers, basically. Now one whole entire type that we have not studied so far, and that type is something called as decimals. So decimals are broadly classified into two types. Again, probably you would have heard these names: terminating decimals and non-terminating decimals. That's the first thing. Now, what are they stand for? So, terminating. So, this word terminate, it means to finish, to end after certain value. So, terminating decimals are the ones we can say simply that they get over after certain value. Example 0.25. Now, after this 5, there is no other value after this. So, it stops at this part. It ends at this point. So all these numbers which end after a certain value, they all are called as terminating decimals. And then obviously there is something called as non-terminating decimals. So non-terminating decimals are the ones obviously that are not gonna stop, that are keep gonna go on and on and on. And these non-terminating decimals are classified into two more subtypes. Again, probably you would have heard them: recurring decimals and non-recurring decimals, for example. Now, again, what are they stand for? So, recurring decimals. So, recurring decimals, as in one particular digit or point of or multiple digits or pattern of digits keeps on repeating itself again and again and again. They all are called as recurring decimals, normally denoted by the bar sign. Example 0.3 bar, which means 0.333333 and so on and so forth. Or it can be any pattern of digits also that can repeat infinitely. They are all recurring decimals. Then there is something called as non-recurring decimals. So obviously non-recurring decimals are the ones which keeps on going and then there is no particular pattern that is there. So all the digits are random digits. Now for example pi, the value of pi we cap it at 3.14, but the point is scientists figured out 100 digits after the decimals, went on dividing 22 by 7 again and again and again, and then turns out they realize all these digits that are there, 100 digits, they all are different. There is no particular specific pattern among them for the repetition part, and hence since then pi is classified as non-recurring non-recurring decimals. So there's a whole separate criteria behind decimals, and now we can say that the major classification of number is kind of done. Of course, there are more varieties in terms of prime numbers, even integer, even numbers, odd numbers, etc., etc. And then few more varieties of numbers that you have to know. But this is the basic part or the beginners level of classification. So I hope you are understanding so far. Uh, let's move on to the next idea. We have to write few definitions, starting with the first one, that is prime numbers. Now, prime numbers, what are prime numbers? Simply, we can say these numbers are divisible by exactly two numbers, one and the number itself. And if they are divisible by the two numbers, we can also say that they have two factors, for example. So, factor is something that will divide your number completely, then it is called as the factor. So we can say natural numbers having exactly two factors, one and itself. They are called as prime numbers. Then obviously there is something called as composite numbers, exactly opposite of this. So the ones which will have more than two factors, they are called as composite numbers. So the number will be divisible by more than two numbers completely. Then they are composite numbers. We can do few simple examples. Suppose these 4 or 5 numbers are given to us and we have to classify them as prime and composite. Obviously, we'll have to factorize them and come to know. So 8, if you factorize, you would realize 8 is completely divisible by 1, 2, 4, and 8. So for example, it has more than two factors. So it becomes a composite number. Whereas 7 is divisible by only two numbers, 1 and 7 itself. So 7 becomes the prime number. And same is the story for 13, and then 9 and 20 are composite numbers because they have more than two factors. So very very simple idea. Numbers which has two factors, prime numbers. Numbers which has more than two factors, they are composite numbers. Then there are few pointers that we need to understand also. So first point is about number one. So number one is neither prime nor composite. Logic is very simple. we have categorized prime numbers as having two factors, composite as more than two factors. If you factorize one has only one factor, which is 1 itself. So hence it is neither prime nor composite. Then point number two, 2 is the smallest prime number and only even prime number. So you would realize apart from 2, there is no other even number which is a prime number. So only 2 is the even prime number basically. So these are the two more pointers that we need to understand. Then moving on, the next one, even numbers. So even numbers are the ones, natural numbers, which are divisible by 2 basically. And now because we are using the word numbers, we are going to focus on natural numbers. Natural numbers is only positive integers. Example 2, 4, 6, 8, etc. etc. Then if they use the word integers, we'll have to consider integer as a broad category which includes positive as well as negative numbers. So integers that are divisible by 2, they are called as even integers. Minus 2, minus 4, plus 2, plus 4, etc. etc. Then odd numbers, natural numbers which are not divisible by 2, 1, 3, 5, 7, etc. etc. And lastly, odd integers, integers that are not divisible by 2, which includes both positive as well as negative numbers. For example, minus 1, minus 3, plus 1, plus 3, etc. etc. So these are the next few types of the numbers, and what we are trying to make you understand is here that the words are going to play a huge role now going forward. So numbers is the word is used. High chances say you need to focus on natural numbers. Integer is the word that is used. Then you need to focus on integer as a whole category, which includes positive as well as negative numbers. So that's the whole idea behind this. Then moving on, there is something called as operation on numbers. It's a very simple idea. What happens is we have been given two different numbers a and b, for example, and we have to perform four operations on them: addition, multiplication, subtraction, and a raised to b. And we have to find out their nature. And the easiest way to do that is you assume some values to to find that out. So for example, if we start with that, so let's say I will assume the numbers. First criteria, both numbers are odd. I will take, let's say, 5 and 3 for example. Slightly darker color. Let's take black. That is the best. So 5 and 3. 5 plus 3, obviously, after adding becomes 8, which is even. Then 5 into 3, 15. That is odd. Then 5 minus 3 is 2, which is even. And 5 raised to 3, 5 cube is 125, which is odd, for example. Then first number odd, second number even. I'll take 5 and 2. So 5 plus 2 is 7, which is odd. 5 into 2, which is 10, which is even. Then 5 minus 2, which is 3, which is odd. And then 5 square is 25, which is odd again. Then first number even, second number odd. Let me take 4 and 3 for example. So 4 plus 3 is 7, that is odd. Then 4 into 3, that is 12, that is even. Then 4 minus 3, that is 1, which is odd. And 4 raised to 3, 4 ka cube is 64, which is again even, for example. And lastly, both the numbers are even in the fourth scenario. 4 plus 2, that is 6, which is even. Then 4 into 2, that is 8, which is even. 4 minus 2, which is again 2, which is even. And 4 ka square is 16, which is also even, for example. These are the conclusions of this entire process, and you will get that we are having the same answer. So the easiest way to do this is I would always assume the numbers. Even if I forget, I will always assume some numbers and then verify, and then get the answer simply in this particular manner. Now let's understand the next concept, which is something called as relatively prime numbers, or it is also called as co-prime numbers. Now, what is this idea? So, very simple idea. We can simply say numbers which have only one common factor between them, they are called as co-prime numbers or relatively prime numbers. That's the words. Very important common factor we have to look at, and it should be only one common factor. If they have more than one common factor, then they are not co-prime. For example, let's do some examples. Suppose 10 and 15. Now if we factorize 10, the factors will be 1, 2, 5 and 10. If we factorize 15, the factors will be 1, 3, 5, 15. Now, if we take common factors, because we are supposed to take common factors, so common factors you'll realize are two common factors, 1 and 5. So clearly, they both are not co-prime because they have more than one common factor. So they are not co-prime to each other. Basically. And this is the way to figure it out in a very, very simpler manner. And you can use that same thing. Similarly, let's say 13 and 20, these are the two numbers. 13 being a prime number, only two factors, 1 and 13, but 20 is a composite number, so more than two factors. These are the factors for 20. If we take common factors, there is only one common factor, and yes, then that means they are going to be co-prime to each other because they are satisfying the criteria. So only one common factor between them, and then they are called as co-prime numbers basically. And this is the way to identify, this is the way to figure that out. Now, few pointers related to this. The first point, that is two consecutive numbers have to be always co-prime, and that is applicable for all the consecutive numbers, all the back-to-back valid two numbers. And then point number two is one is always co-prime with all the other numbers. So number one is always co-prime with all the other numbers. So these are the few pointers that we need to remember or understand when it comes to co-prime numbers or relatively prime numbers, as the definition suggests. Now, moving on, the next part of concept is something called as converting a recurring decimals to a fraction. Very important. Let's take a number, for example, 1 by 9, which is 0.1 bar. Now, why this is 0.1 bar? Let me give you a small background behind that. But before that, for people who do not know, just remember one rule: 11.11% is 1 upon 9 as a fraction. So this is one thing that is required for you to remember this or understand this concept. So let's take the first number, which is, let's say, 0.1 bar, which can be also written as this 0.1111 dot dot dot, because it is repeating infinitely, hence it is written as recurring decimal. Now the same number can be also written as 11.11 divided by 100. Reason being, whenever we divide any number by 100, the decimal shifts two places on the left side. So if we shift the decimal two places on the left side, we end up getting the same number, which is 0.1111 that we have discussed earlier. And now 11.11 divided by 100 can be also said as 11.11%, because percent in any number, if you want to find out the percent, we divide that number by 100, for example. And we have just now seen 11.11% is actually 1 upon 9. So our answer is done. Whatever was the recurring decimal, we had to convert it to a fraction, and the fraction for that number is 1 upon 9, and this is a small 2-3 liner proof for that, that how it is 1 upon 9, for example. Instead of remembering, this is the way to actually do that. Now what I will do is I will take some few more examples so that you understand even more clearly, because I want to prove some point, and for that all these calculations are necessary. So bear with me for some time and let's try and understand more such numbers. So let's say 0.2 bar, for example, can be written in the same manner as this probably, and then can be written as 22.22 divided by 100, which can be further rewritten as 22.22%. Now again think about this. 11.11% is 1 by 9. So 22.22% is double of that. So the percentage is doubling. The fraction should also double, and 1 by 9 ka double is 2 by 9. So that is your answer for 0.2 bar, which is 2 upon 9 in terms of a fraction. A point is, let me do few more and I will skip some steps now. 0.4 bar, I can say 0.444, which is 44.44%, which is 4 times of 11.11. So fraction also becomes 4 times, which is 4 upon 9. Then 0.5 bar is 55.55%, which is 5 times of 11.11, hence 5 by 9. 0.7 bar will be 77.77%, which is 7 by 9. 0.8 bar is 88.88%, which is 8 by 9, and so on and so forth. So the reason to do all these examples, that is, going forward we have to remember a simple rule, and that rule is, if you ever wish to recur a single digit, all you have to do is divide that digit by 9. So let's say you want to recur 1, divide 1 by 9. You want to recur 2, you want to repeat 2 infinitely, divide 2 by 9. You want to repeat 5 infinitely, divide 5 by 9, and so on and so forth. Any single digit, if you want to recur, if you wish to recur that digit, repeat that digit infinitely, all you have to do is divide that digit by 9. And that is the theory that you need to understand and remember. There are few more varieties about this type, which we are going to see in the questions immediately now, after this whole aspect. So this is the way to do that. Then there is one more, that is 0.23 bar, and now we have to repeat two digits, right? 2 as well as 3. We just now saw this theory. You want to repeat one digit, divide that digit by 9. If you want to repeat another digit, divide that digit by 9. So that means that gives you the same answer, which is 23 by 99, for example. And this is the way to look at it for solving purpose. So these are the concept, folks. And now, basis this, we'll do some 7-8 questions so that you understand how this whole process happens of solving these all questions. So let's start with the first one. This is the first question, which says 4x plus 7y is equal to 108, and x and y are natural numbers. What can you say about the value of y? Very simple and straightforward question, but you still have to get it right, because a lot of people end up missing this. We should not be missing such simpler, easier level questions, for example. So how do we do this? So what we need to do is understand something about the nature of these numbers, for example. So let's say 4x. Now think about this. This 4x is even or odd? So clearly this 4x is even. This 108 is also even. And even plus what gives you even as the answer? So clearly even plus even gives us even as the answer. Why 4x is even? Let's take some numbers. So for example, 4 into 1, 4, 4 into 2, 8, which is even. 4 into 3, which is 12, which is even. So 4x is always going to be even, irrespective x is odd or even. I hope you get that. 108 is always even because the number is even itself. So even plus what is even? So have to be even only. So this 7y have to be even. Now think about this. If I substitute y as 1, so 7 ones are 7 and that becomes odd, which we do not want. We want 7y to become even. But 7 twos are, if we substitute y as 2, this becomes 14, this is even, which is what we want. 7 threes are 21, odd, we do not want. But 7 fours are 28, we want because it is even. So the whole idea is for 7y to be even, I hope you have understood the simplest pattern that your y has to be even. If your y is odd, then 7y also becomes odd, and then even plus odd gives you odd, whereas we want even number as the final answer because 108 is even. So I think the answer has to be y is compulsorily even because only then 7y becomes even, and then even plus even you get the answer, as even. That is the way to look at it. I hope you have understood this first one. So answer have to be y is always even. Now the second question is slightly different than what we have seen so far in our questions that we have discussed. So there are two ways to do this. One is a lengthy way of solving the entire expression and then getting the answer, versus the other one is slightly easier shortcut method. So what I'll do is I'll straight away discuss the shortcut method only, so that you guys will use that and get the answer faster. So in such types where some numbers are recurring and some numbers are not recurring, how do we do? So in the numerator, you have to write down the entire number as it is. So forget the decimal sign, forget the bar sign. You write down the entire number as it is, and that entire number is 537. And from that entire number, what we have to do is we have to subtract the non-recurring part. So the non-recurring part is 5. So 537 minus 5, and you get the same answer, which is 532. And in the denominator, what we are supposed to do is for all the recurring digits, we are supposed to use those many nines. And for non-recurring digits, we are supposed to use zeros. So here we have two recurring digits. So we are going to use two nines, and we have one non-recurring digit, and hence we are going to use one zero. So you get the same answer as what they have also gotten after solving the entire expression and then doing calculation and then getting it. So this is the fastest way to do that. So do remember the formula or the structure, and yeah, here it is. So that's the best part. So in the numerator, entire number as it is minus the non-recurring part, and in the denominator, number of nines for recurring digits and number of zeros for non-recurring digits. And this is the way to do that. So that's our second question. Question number 3 is exactly basis the same idea that we have just now did. So in the numerator, we'll write down the entire number as it is, which is 7624, minus the non-recurring part, which is 76, and in the denominator, two nines for recurring because two digits are recurring, 2 and 4, and two zeros for two non-recurring digits, which is 7 and 6, for example. So this is the way to do that. Question number 3. And 7624 minus 76 gives you the answer as 7548, for example. Then there is one more variety, 5.163, where 3 is recurring. Now this is different than what we have done so far. The reason being is that so far we have done all the questions which started with 0 point something. Now this is a different one because it is starting with 5 point something. So in such type there is a slight difference, but that difference is only gonna be there in the denominator. In the numerator there is no change. You're gonna proceed as it is. So in the numerator we'll do the same thing, that is entire number as it is, which is 5163, minus the non-recurring part, which is 516. But in such cases where you have integer point something, in such cases, while writing the denominator, that is number of nines and number of zeros, in such cases, what we need to do is we need to only follow the digits after the decimal. So after the decimal, whatever is the status, we have to only consider that, not before the decimal, only after the decimal. So after the decimal, what is the scenario? So there is one recurring digit, so there will be 1 9 because 3 is recurring, and there are two non-recurring digits, 1 and 6, so there will be two zeros, for example, for 1 and 6 respectively. So the answer becomes 4647 divided by 900. I think first answer option is the answer for this particular question. So integer point something, while writing the number of nines and number of zeros in the denominator, you have to only consider the part after the decimal. Before the decimal, there is nothing to be considered there. Numerator, you will not change anything. In numerator, you will proceed as it is, whatever we have done earlier in the previous two questions as well. So this is the way to do that. So we have covered all the varieties that are possible in such type of question, that is converting a recurring decimal into a fraction, for example. And that was our question number 4, people. Let's do question number 5, which says capital A is 0.A1, A2, A3, A1, A2, A3 dot dot dot, and capital B is 0.B1, B2, B3, B1, B2, B3 dot dot dot. Now clearly after this point you should realize one thing, that dot 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 represents they are recurring, which is 0.A1, A2, A3 bar, and capital B is 0.B1, B2, B3 bar, for example, because they are recurring numbers. So that's the first thing we need to understand about recurring numbers. Also, they said that A1, A2, A3 and B1, B2, B3 are distinct integers between 1 and 9. Now, distinct is different. Integers, non-decimal numbers, proper numbers between 1 and 9. So that also tells you something, that these are all single digit numbers, A1, A2, A3 and B1, B2, B3, because they are between 1 and 9. So this should also tell you something else that we have learned in the concept. We want to recur a single digit number. We know we divide that number by 9. So here also we can say A1, A2, A3, because we are recurring 3 digits. So we have to divide by 3 nines, and capital B becomes B1, B2, B3 divided by 3 nines. because they are all single digit numbers. So one single digit number we have to recur, we have to divide that by 9. And three numbers we are supposed to recur single digit, so we are dividing by three nines. And now they are asking which of the following is also an integer. And now we have to take help of the options. Now there is something common in all the options that you would see, and that is a plus b. So that is how we come to know we should also be doing a plus b for us. So if you do a plus b for us, we have to add these two. So if we add these two, since the denominators are same, the numerators will be added, and we get a1 a2 a3 plus b1 b2 b3 upon 999 as the sum. And also one more thing that is happening, that each of these numbers is multiplied with a number a plus b. Every time a plus b is multiplied with a number. So obviously if we multiply here on the left side, it should also be multiplied here on the right side. And they want this entire expression to result in an integer. And we know now integer are the numbers that are non-decimal numbers, for example, which do not have the decimals, which do not have the points. So the only way that is going to be possible is that this 999 divides this entire number completely. And now all we have to do is figure out from the options that whichever is that number which is gonna which will be completely divisible by triple nine. So the first one 4 times 9, no. The second one 5 times 9, no. Third one is the answer 19980, because triple nine twoza is 1998. So that means 20s will give you this. So this is the only number that is going to be completely divisible by triple nine, and hence that entire number turns out to be an integer, because integers are non-decimal numbers, for example. So see, what we have learned is, first you have to understand the concept. They are, you see that they are coming two, three times again and again, dot dot dot. So they are gonna repeat infinitely. So bar sign. Then we came to know they are single digit numbers between 1 and 9. So recurring wala concept, divide by 9. And lastly, we proceed according to the options. So all the options had a plus b. So we also did a plus b, and they want entire number to be an integer. So whichever number is there, it should be completely divisible by triple nine. Only then that entire expression becomes an integer. This is the way to think about such questions. Yeah. Let's do the next one. Question number 6. How many three-digit numbers are there that are divisible by 6? Now, to do all such questions, there is no way you can manually figure this out, because there are 900 three-digit numbers from 100 to 900. You cannot count each and every number which is divisible by 6. So, do all such questions. There is a simple formula that you can remember going forward, and that is the whole idea behind this. So, the formula is very simple. It is uh, last multiple minus first multiple, the whole thing divide by 6, because we are looking at numbers that are divisible by 6, and the whole thing plus 1. So the entire formula will remain as it is for all such type of questions. And this formula actually comes from the concept of arithmetic progression, AP, the nth term of AP. So whenever you'll study that, you can think about this idea, and you'll get the same formula. So this is the formula, and now we have to again figure out this whole calculation. The last multiple, as in the biggest three-digit number that is divisible by 6. So the three-digit number, the biggest number is 999, but whether it is divisible by 6, no, because it's an odd number. So 998, whether it is divisible by 6, no. Then 997 is odd, so out. 996, whether it is divisible by 6, then yes, 996 is the number which is divisible by 6. So last multiple is confirmed, it is 996. Then first multiple, first number, three digit number that is divisible by 6. The first three digit number is 100. Is 100 divisible by 6? No. 101 is odd, so not there. 102, yes. 17 6 are 102. So 102 is your first multiple. Now the only thing left for you to do is substitute the values in the option, I mean in the formula, and you get your final answer. This becomes 996 minus 102 is 894 divided by 6 plus 1, which is 149 plus 1, which gives you the answer as 150 values. So this is the way to do that. And let's say you want to find out how many 5-digit numbers are there that are divisible by 13. The formula will remain the same. There will not be any changes there also. So that is the whole idea behind keeping this concept, and that is why you have to remember this very very clearly. I hope you have understood this question number 6. Let's understand question number 7. Find the largest integer n for which this entire expression will be a natural number, and also for how many values of n this entire expression will result in a natural number. So there are two questions here that we need to find out. So this entire expression has to be a natural number. So let's first simplify this expression, and for that what we can do is we can simply divide all the numbers by n, for example. So 16n square divisible by n divided by n, you get 16n as the answer. Then 3n by n, you get 3 as the answer. And then 6 by n, you get obviously 6 by n as the answer. Now this entire number to be a natural number. Now imagine if n is a integer. So clearly if you multiply 16 with that, you get integer or a natural number, proper number basically, which is a non-decimal number. 3 is a constant number any which ways, so it doesn't really matter. So that means the entire dependency now is on 6 by n. So for this entire number to become a natural number, 6 by n has to be a natural number, for example. And that is the whole idea behind this scenario. Now we have to only think about this possibility where 6 by n is a natural number. Now when that will happen, only when the 6 is completely divisible by n, which is below that. So obviously n has to be a factor of 6, because 1 2 3 6, these are the only four numbers that will divide 6. Any other number you substitute there is not going to divide 6. For example, if I substitute there 4 n ki jagah pe, so 6 by 4 is not an integer, it's a decimal number. 3 by 2, which is 1.5. And then if that becomes a decimal, then entire number becomes decimal, because we are going to add them together. So I hope you are getting. So the two answers are, the one is how many values n can take. Obviously, four values n can take. And the second one, what is the largest value n will take? Obviously, 6 is the largest value that n will take. And this is how you can solve this particular question. So, see, the point is you had to know what is natural numbers. If you do not know what is natural numbers, then you will not be able to solve this particular question. Now, suppose if we change this question, instead of saying that it's a natural number, if it is an integer, rest everything remains the same. And now comes another revelation, because now we want integers, and integers can be positive and negative. So in this case, n can take four more values: minus 6, minus 3, minus 2, minus 1. But 6 still remains the largest number. So the whole idea is that we need to be very aware of the fact that what is integer, what is natural number, and only then you will be able to get it right. Otherwise, you will make a very small and silly error and end up losing all your marks in such manner. So be very careful while reading the question and try and identify the key parts, that what exactly it is and how it is supposed to be done. Basically, so that's the seventh question. Now let's do the next one. That is question number 8. For example, it says there are 24 numbers that can be formed using the digits 2, 3, 4, and 6 only once, and we have to find out sum of all such numbers. Now, again, practically impossible to find out all the answers by forming all 24 numbers and then adding them. Not possible. So, you need to understand some pattern. So, first thing you need to understand is there are only four digits and repetition is not allowed. So, all these digits are supposed to be used only once in a number, and there are still 24 numbers that are being formed. Now, when that will be possible? So, only and only when every digit will come six times at each place value. For example, let me do six such numbers and then probably you'll understand what I meant by that. So, what I will do is I'll form all the numbers that are starting with 2000, for example. So, let's say 2000, and let's do some combinations now. See, other digits are 3, 4, 6. So 2, 3 is done. So that means 4, 6 and 6, 4. Then 2, 4 is done. That is 3, 6 and 6, 3. Then 6 is done. So 3, 4 and 4. So these are the numbers, the six numbers that are starting with 2000. I hope you understand. Similarly, there will be six more numbers that will start from 3000. Similarly, six more numbers that will start from 4000, and similarly, six more numbers that will start from 6000. So hence 24 numbers are being formed overall using these digits. Now to add these numbers, what we will do is, since the digits are going to be same, let's add the digits only, that is 2, 3, 4, 6, which gives us 15. And as we discussed, every digit is going to come six times at every place. So here you are seeing that the thousands placement 2 has come six times. Similarly, 3 will come six times. Similarly, 4 will come six times. In hundreds place also, all the digit will come six times individually. 3 will come six times, 4 will come six times, and so on and so forth. So hence we'll do into 6. So 15 into 6, that is 90, for example. And now only thing left for us is to multiply this by place values. So 90 यूनिट्स प्लेस पे आ गया तो 90 ही रहेगा. टेंस प्लेस पे आ गया तो इंटू 10, यानी 900. हंड्रेड्स प्लेस पे आ गया तो इंटू 100, so 9000. एंड थाउजेंड्स प्लेस पे आ गया तो इंटू 1000, which gives you 90,000. And since we are supposed to add all of them, the sum of all these numbers turns out to be 99,990, which I think is answer option 5. And this is the way to do that. How do you come to know? Now think about this. When two is at the thousands place, hundreds place में 3 has come twice. Now there will be some numbers जहाँ पे 3 will be at the thousands place, तो वहाँ पे 3 नहीं आ सकता hundreds place पे of course. तो जब 4 होगा thousands place पे तो वापस 3 will come twice at hundreds place in some numbers. And then जब 6 होगा thousands place पे तो again 3 will come twice at hundreds place. I hope you understand what I'm saying. And hence we come to know कि 3 जो है वो hundreds place पे कितने बार आ जाएगा, 6 बार आ जाएगा. Similarly 4 आ जाएगा, similarly 6 आ जाएगा. All the digits will come at every place 6 times. That's the pattern. Now how why we are then adding the digits and then multiplying it by the place values and then simply adding them up. So logic for that is, let's take a number, let's say the first one only, that is 2346 for example. How does this number actually formed? So for example, what we'll have to do is, because 2 is at the thousands place, we'll have to multiply by 1000. Then 3 is at the hundreds place, so we'll have to multiply by 100. 4 is at the tens place, so we'll have to multiply by 10. And 6 is at the units place, so we'll have to multiply by 1. And we'll have to add all these numbers with each other. So this becomes 2000 plus 300 plus 40 plus 6, and that gives you the final number, that is 2346 for example. So to add the numbers, because the digits are going to be the same digits, just their position is changing, what we did is we added the digits only. And the digit ka addition is 15. And every digit is going to come at each place 6 times. So hence we multiplied by 6. And hence we simply multiplied by the place value to get the correct judgment. This is the way to do such questions. So remember this kind of technique to solve all such similar questions. So that's answer option 5 for question number 8, folks. Now next 3-4 questions will not be doing. The reason is base system is not the part of the syllabus, so you can skip that, you can ignore that, and that means we are done with number system. So go through this one more time all over again. And if you have still any queries or any questions, do let us know. We'll be happy to help you guys. So see you in the next class with another topic of numbers. Till then, take care. Bye bye.